Alright, we are back with normal distribution area above or below a point. Normal distribution area above or below. Problems I'm going to be working on today are pretty straightforward. I'm looking to find proportion that is greater or less than the questions that are asking. So we have over here the problem. A set of silver prices normally distributed with a mean of 2,500, standard deviation of 200. Here's my first two data points. Problem number one, mean equals 2,500 and SD equals standard deviation equals 200. So my variable is 2410, and I want to find what's higher. Oh right, I don't have the thing on. So my variable equals 2410. And I want to find what's greater than the variable. It's a pretty straightforward calculation. We take the how is it again? The variable minus the mean minus the variable. No, variable minus the mean. So if this is lower than the mean, we're going to get a negative number. So 20. Alright, let me write this down for you guys first. So the variable minus the mean over the standard deviation equals the z-score, or proportion. How do I describe this? Distance from mean. Okay, so this equals 2410 minus 2500 over 200 equals 90 over 200 equals 45%, 0.45 z-score. This is the distance from the mean. So I take this and I put it into a z table. Oh, and I think I took off the table from what I was looking up. Crap. Alright, let me just look at a regular table. Okay, ztable.com. How about that? Alright, and look at this. It explains to you what the purpose of the z-score table is. If you have values on the left of the mean, you're going to get a negative z-score, and this is going to represent the area under the curve to the left of z. That means the proportion that is less than the value. We got negative 0.45. Negative 4, and the fifth column is here. Okay. Negative 45 is 32.326. Whoops. 0.3264. Whoops. 0.3264. Let me check that again. 3264 for 0.45. And because this is looking for greater than the proportion, this shows below the point. So if I want above the point, I have to take the inverse. 1 minus 0.3264 equals 6736. Plug it in. Yay, 3 more. Okay, let's try to do this one a little bit faster. So I'm looking for lower so I don't have to do any other calculations. 105, 10, and 90. Okay, question 2. Mean of 105, standard deviation of 10, and value of 90. Did I read that right? 90.4. That would make a difference. So this is to the left of the mean. 90.4 minus 105 over 10 equals negative, not going to calculate it, let's just 14.6 over 10. Hold on, let me double check that because I don't like to leave things to chance. 90.4 minus 105. Yep, nice. And then dividing by 10, I don't have to worry so much. Negative 1.46. Holy crap, what's happening on my phone? Okay, so if I look at the z table, negative 1.46 is over here. Okay, so column 6, 1.4 is 0.0721, 0.0721. Hold on, let me pause this real quick. Okay, so what do we have here? That is our z-score. Oh, yeah, this is the proportion of people that are below the question number. So, speaking in other ways, right? You have a mean of 105 and standard deviation of 10. 90.4 is 2 standard deviations, or wait, it's like two standard deviations below the mean. So it makes sense that there is 7.21% that are below that value. Okay, let's finish this off. All right. Temperature is mean 19.7, standard 2. What was it again? 21.4. Oops. 19.7. 2 and 21.4. 21.4. So this is greater than the mean. What am I looking for? Higher. Okay. So we take the value, so we have 21.4 minus 19.7 over 2. 0.85. Put this on the table. .85 is going to be 80.23. And since we need the inverse, it's going to be 1 minus 10. 1 minus 0.8023 equals 1977. The 19.77% is higher than the value in the example. Okay, one more. Here we go. 86.95 and lower. Okay, so we don't need to invert it. 86.95 for u equals 80. O equals 6. V equals 90. Double check. 95. Man. So 95 minus 80 over 6. 15 over 6. 15 divided by 6 equals 2.5. Take the z-score, 2.5. Perfect, 99.38. Okay. Yay. Area between 2 points. I have to take two z-scores and minus them from each other. This is kind of a pain in the butt. Alright, here we go. Let's just get on with it. Alright, let me make a new area for this. Area between 2 points. Okay, here we go. 76 and 10. And what's my two values? Actually, point A and point B. Let's see. $63 and $90. Let's go. $63.90. So let's pretend like I'm going to program this later. I'm going to take my standard deviation. No, I'm going to find z-score A equals 63 minus 76 over 10 equals 7 plus 6 equals 13. 13 over 10 equals 1.3. Oh. Z for V equals 90 minus 76 over 10 equals 24. Right? 14, Jesus. Over 10 equals 1.40. So if I'm going to find the z between these two, I know I have to find the difference, right? So I have a difference of, so ZA minus ZB equals 1.3 minus 1.4 equals negative 0.1. I hope I'm doing this right. And that's going to be the area between the 2 points. 0.1 is two very different values. Let's see, 4602. Oh, wait a minute. No, I think I got something wrong. Hold on. Okay. So let's think this out. Over here, we have our 76. We have A over here, and B over here. B is 90. Alright, let's finish conceptualizing this. Oh man. So 63. So the z-score for z of b, the z-score of this proportion, oh wait, I need to get the value. 1.3 or 1.4, right? I have 1.4. So the area under 1.40 is 9192. .9192. And the area under 63 equals 9032. So if I take the bigger proportion minus the smaller proportion, then I'm going to get, so I'm taking, so 63 below represents this, and the area for B is like the entire thing, right? So B minus A equals the between. .016. Let's see. 0.016. Oh. No! Alright. So I did that right. Did that right. Did that right. Did that right. Oh, I have to invert. Oh, decimal place? Wait a minute. What is going on here? Negative 1.3? that's right. Silly mistake. Negative. Man. To the left of the main, I need to remember this 0.90, 0.0968. 0.0968. Okay, 0.9192 minus 0.0968. 0.9192 minus 0.0968 equals 8224. So silly. Silly mistakes. 0.8224. Okay, let's do the second problem without mistakes. 58.5. Oops, I don't want that. Alright, you need to get unpinned, man. What the hell's going on here? Unpin. Dude. Okay, so 58 and 5. 2. 58. 5. A is 48, 50, and 60. Okay, so CA equals, okay, this is going to be a negative number. Oops, not a meg number. Negative 48, 50 minus 58 over 5. (48.5) minus 58 negative divided by 5 equals negative 1.9. (60 minus 58 over 5). 2 over 5. 2 divided by 5 equals 0.4. So I'm going to take the big area minus the little area. How about that? Big, or pause, minus little, neg, or whatever could be approximated, right? So the z-score for 0.4 6554. 6554. This is B minus A, which is negative 1.9. (0287). .6554 minus 0.0287. 62, 67. 62, 67. Excellent. 6267. Yay! Oh, pain in the ass. Okay, two more. Oh. 1057. Seven A B 94.5 and then 115.5. All right. 94.5 CA minus 105 over 7 equals negative 1.5 equals 115.5 minus 105. 7. $1.5. Nice. Negative 1.5.0668. Then 1.5 93.32 big minus small. All right, 0.8664. Yay, last one. Okay. 750 and 60. $624 and $768. $624, $768. Okay. So we have our small number. $750. Oops. 650. 624. 624 minus 750 divided by 60. 2.1. 768 minus 750 over 60. Equals 18 divided by 60. equals 0.3. 2.1, negative 2.1, 0179, 0179, 0.3, 6179. So the space between the two, for my last problem, I'll draw this out for you guys. Okay, so we have a mean of 750, and point A is here, point B is here. They'll say this is 624 to 768. This area is represented by the z-scores of 0.6179, which is the whole thing minus the z-score for 624, which is 0.0179. Minus 0.0179 equals 0.6000 if you need some extra decimal points. 0.6. Nice. Just one silly mistake holding me back. Alright, I'll do more of this later. That's it for now, guys.